Ten more days until Thanksgiving break. You can do this. All right. Let's look at this bell work. Because it is going to get us ready for what we're doing today. So, if I'm trying to solve this guy here, my x squared minus 100 equals 0. We have a couple of different approaches now, but what's your first instinct here? Add 100. Valid. So let's add 100 to both sides. It's kind of the way I was hoping we would go, because it sets us up for what we're doing today. So we have x squared equals 100. Then what? Square root it. Radical. Yep. So we're going to have x equals what? Square root of 100. Or negative 10. So whenever we square root an equation, we get our plus or minus. Whenever I'm square rooting on both sides of an equal sign, that's when we put our plus or minus. So plus or minus, our square root of 100. Square root of 100 is 10. Then let's look at our right side one, and we're asked to factor this. What do we do? Looking over here. What do we notice? How will we start? Yeah, we can do it with the x style. So we're going to put our a times c at the top. So my a is 1. My c is 4. So 1 times 4 is 4. And my b goes at the bottom, negative 4. That's my b. We need a pair of numbers that multiplies to make positive 4 and adds to make negative 4. What is that pair of numbers going to be? Negative 2 and negative 2. Negative 2 and negative 2. They both have to be negative in order for it to add up to be a negative 4 and multiply to be a positive. If our top number is positive, so if our a times c is positive, our signs will match on both pieces. They'll either both be negative or they'll both be positive. So going through this, our x squared goes in the top left. Our 4 goes in the bottom right. Our two pieces in the x frame get whatever this middle variable is. We have minus 2x and minus 2x. So what are our factors going to be? Negative 2, x, and negative 2. So we get as a factored form x minus 2 times x minus 2. Or x minus 2 squared. This was a perfect square trinomial. We could have taken one of our shortcuts from yesterday. Shoot. We could have taken a shortcut, but we don't have to. It still absolutely works. But if we can start trying to spot those, it will save us some time and effort with what we're doing. Because today what we're going to do is we're going to take our perfect square trinomials and our solving stuff with square roots and smash them together. We're going to use both of these ideas in what we're doing today. Okay, so questions on either one of these? Okie dokie. So, we're going to start with just hopping straight in on one of them. We're solving with a square root property when we have perfect squares. So solving with the square root property just means when I square root both sides. That thing we did with the x squared equals 100. And so here we have x squared minus 4x plus 4 equals 25. Well, we just saw this first half thing. this piece, which, why is my pen super skinny like that? How did that? This piece, we just did in the bell work, not with the 25. I got distracted by the fact my pen looked really skinny. This piece, there we go. That's the chunk we did in the bell work. We looked at that thing. That is our perfect square trinomial. If we have a perfect square trinomial, we do not have to set it equal to 0. It's the only time we don't have to set it equal to 0. Since this is a perfect square, I could factor just this chunk as we did in the bell work. That was our x minus 2 times x minus 2 equals 25. Changing that color. Or we could write this as our x minus 2 squared equals 25. So when we have that perfect square trinomial, I do not have to set it equal to 0 if I can get it as a perfect square. Because if this was just, I'm going to hypothetically do one over here to the side. If this was just x squared equals 25, bless you. If we looked at this one, what would our next step be? Square root both sides. So what should we do over there?
Square root.
Square root both sides. I have an exponent on the outside. To undo the squaring, I'm going to square root. So, don't want that. There we go. So we're going to go ahead and square root both sides of our equation. I do that because my square root and my square cancel out, and we're left with x minus 2 equals, what do I get when I square root both sides of an equation? And we're doing the square root of 25. Or, I square root of both sides of an equation, so we put our plus and minus. It could be positive 5 or it could be negative 5. We're going to wind up with two solutions here. Since I have a plus or minus, I'm going to split it into a plus, minus. Two different equations to solve. So we're going to set it up as x minus 2 equals 5 and x minus 2 equals negative 5. So finish solving these out down here. X minus 2 equals 5. What's x going to equal?
Negative 3. Wait, where?
I'm looking at the left one. This one. X minus 2 equals positive 5. What do we do?
7.
We add 2 to both sides. 5 plus 2 gives me 7. On the right-hand one,
Negative.
add 2 to both sides. Negative 5 plus 2, we get negative 3. If we had set it equal to 0, we would have gotten the exact same factors. We would have just had to do the whole x and box situation. So it's getting us to those same solutions. It's still getting us to our x-intercepts. This one's just less factory. So if and only if we have a perfect square trinomial, can we not set it equal to 0? So it has to be a perfect square. So we're going to look at a couple more like this. But questions on this first one? Okay. Here's our next one. I got x squared plus 24x plus 144 equals 192. And we look at it and go, ew. Because those are big numbers. Gross. But what I want us to spot or to try and see here is that, bless you, x squared is a perfect square. 144 is a perfect square. Bless you. The allergies are allergying today. Like, it's for realsies. So I know that x squared is a perfect square because that's how it's straight up written. What squared gives us 144? 12. This is the same thing as 12 squared. So let's see if this middle term makes this be a perfect square trinomial. That's when we need it to be 2 times the front piece, my x, times the back piece, the 12. Is 2 times x times 12 the same thing as 24?
Yes.
Yes. So this is a perfect square trinomial. So we can take our shortcut. Our shortcut is when we have our factors, which are going to be identically the same, so it's going to be a perfect square, where we have our front piece, our x, our back piece, that 12, and they get whatever sign is in front of this b term. So they're going to get a plus. And we have this equal to 192. So this line was just seeing, verifying. Okay, perfect. Yes, dear. The pink one? That's from yesterday's special patterns. That middle piece has to be 2 times the front times the back. Has to be, in order for it to be a perfect square. Okay, so if we have a perfect square trinomial, I do not need to set it equal to 0. And there's going to be reasons why this is helpful. I promise.
I don't like the square root.
That's why we didn't want to try and factor it, because it was not going to factor properly. And this is honestly easier than the other way of dealing with those that are super gross. So what do we do next trying to solve this? Square root both sides. Square rooting both sides of an equation. My square root and my square cancel out, so we're left with x plus 12 on the left. What do we have on the right-hand side? Square root of 192. What goes in front of it? I square rooted both sides of an equation. Plus or minus. Square root of 192. Does square root of 192 simplify?
No.
No.
Are you a little? We typed it in a calculator. Does it give us anything?
8. Yeah.
So it does simplify. It doesn't simplify prettily, but it does simplify into our simplified radical form. That would be 64 times 2 makes 192. But we can use our calculators to help us simplify. This is going to be 8 square root of 2. Is or 3. Sorry. Right? That's what I have written down. Is that what the calculator said? 8 square root of 3? I don't have my calculator over here.
Yeah.
Okay, thank you. So it does simplify. It's just not pretty. It's decimally and gross. We have an irrational root. But we can deal with that. So just like we did on the last one, I'm going to split this to be a plus and a minus, because we're going to get decimally answers. So we want to set up as our x plus 12 equals the positive 8 square root of 3, gross, and x plus 12 equals negative 8 square root of 3, gross. I do need to get my x by itself though. What do I do to get my x by itself on both of these? Subtract 12. I was just hitting the button for my calculator so we can do the decimal answer here in just a second. So I'm going to subtract 12 from both sides. So that's going to give me x equals, and I don't care if you write it as 8 square root of 3 minus 12 or negative 12 plus 8 square root of 3. Either way is totally fine. I'm just going to do this 8 square root of 3. Just make it really clear where your square root ends. Minus 12. Because the minus 12 is not under the radical. And on the other side, we wind up with a lot of negative signs. Subtract 12 from both sides. We have negative 8 square root of 3 minus 12. So they're very similar. They look really close, but they are not identical. But that doesn't super help if I was trying to sketch stuff. So let's get some decimal-y answers. So what we do to do that is we're just going to type those answers exactly in. We had our 8 square root, which we hit the green button, and then we hit the x squared button, and it'll get you our square root of 3. I need to make sure I get out of my radical, so I'm going to hit that right arrow to get out of the radical. See how my radical stops then and it's not over my blinky line? That means I'm out of the radical. Minus 12. Calculator's going to try and simplify it for you, which it doesn't see anything it can simplify. So to get our decimal answer, we hit the little 2 arrows above the enter button. And that gives us a decimal approximation. I'm going to take 3 decimal places. So I'm going to take 1.856. So this about equals 1.856. We're rounding. If we were properly graphing this, I'd say probably take it as 1 decimal place, 1.9 would work. We will usually tell you how far we want you to go on like a quiz or a test. We'll tell you how many decimal places. I just kind of default to 3. Thousands is always a good safe bet. And then we do the same thing to get a decimal approximation of the other one. That's what the squiggly equal sign means. It means about our decimal approximation. So we're just going to type it in the calculator. Same vibe. I'm going to have my negative 8 square root of 3. Make sure you use the negative sign that's down here, not this minus sign. To get the square root, you hit the green button up here, the second, and then you hit the x squared. It undoes squaring, so it's right above the x squared. That's why they put those together. There's a lot of things that are like that, and as we start getting into stuff next semester, we'll notice that with some of these pieces and these pieces and these pieces that they're opposites of each other. So our square root comes from the green button and then the x squared button. And so we've got my negative 8 square root of 3, and we are going to subtract, I'll raise the pen, there we go, subtract our 12. And again, it's going to try and simplify it, but I want decimal, so I hit the 2 arrows above the enter key, and I'm going to take 3 decimal places again. So I have minus 25.856. So we're getting super icky, gross roots. But we didn't have to try and factor that. So, what happened? Let me see. Use negative, so multiply negative 12 times this.
Oh.
So make sure you use the minus sign.
Okay.
Yep. That is a super common mistake, and also why I highly encourage you guys to do this along with me. It helps us spot those little bitty mistakes, because in a test, I can't tell you if we do things wrong or right. Practice using the buttons. It's why I show you the things. Promise. I don't do this just to torture you. Promise. Promise. Okay. I know it's a Friday. I know we're kind of zombies. One more. Just one. Just one.
Ew.
It's icky, but I promise we can do it.
Hey, we can divide all of them by 2.
We have a greatest common factor. Oh, snap. Big numbers, but all of them are even. We love an even thing. Just like finding hair attached to absolutely everything I'm wearing today. What is going on? Like I just pulled a hair out of inside my necklace. I am attacking myself today.
Fell.
All right. So several of us already spotted this, but this does have a greatest common factor. We want to do that first. All of these numbers are even. So what I'm going to do is I'm going to pull this out as a greatest common factor, 2. When I take 2 out, what we have left over is x squared minus 46x plus 529. It's still unpleasant, but it's less unpleasant than 1,058. And it equals negative 72. Since we are trying to solve, I would really like for that 2 to go away to the other side of the equal sign. So what could I do to get rid of the 2 entirely?
Divide by 2.
Divide by 2. Because we're trying to get this thing solved. So I would really rather not have a 2 over here. So I'm going to divide this side by 2, and I'm going to divide this side by 2. So I've got my x squared minus 46x plus 529 equals negative 36. When we give you obnoxiously big numbers like this, take a pause or 3 and see if there's something that's going to make this easier, like if this is a perfect square. So we know x squared is a perfect square because it's a thing being squared. Like by definition, it has to be. Is 529 a perfect square?
Yes.
Yes.
What is it squared?
23.
23
How do you know
squared.
that?
So you can, in the calculator, you can go,
Serious question.
no, valid. Green button, x squared button, get our square root and type in 529. Boop,
Okay.
23. Pops it out.
Bet.
Okay, so feel free to check that. Anytime we give you an obnoxiously big number, we usually chose it on purpose. Not going to guarantee every time, but almost every time we've chosen it for some reason on purpose. It's a perfect square. So then let's do our really quick double check and make sure this is a perfect square trinomial and not just some random big number. So we want to make sure that this middle number, this 46, is made up of 2 times the front times the back. So 2 times x times 23.
Yes.
So we are a perfect square because 2 times 23 is 46. It's a perfect square, so we're ready to rock and roll. We can write this in our perfect square form.
Wouldn't one of them be a
Oop,
negative?
I heard a what?
Because it's Negative 46.
I don't know how this works.
I was like, we went really deep into these yesterday. So it's not that we're going to have one that's a minus sign. They're a perfect square. They are perfectly identical. They absolutely match. They're both going to have this sign, the minus sign. So if we put this through you could absolutely put this through the x in the box on that left-hand side, but we're going to wind up with our x using that minus sign in between and the 23 squared equals negative 36.
How do you just get rid of everything?
This was using this is because it's a perfect square trinomial, which is what we worked on yesterday, so you probably want to go catch up on that one. It's a shortcut. Yesterday we did a couple of shortcuts. Since it's a perfect square, this becomes x minus 23, x minus 23. If we were to factor it, we would wind up there, which we can rewrite as x minus 23 squared. So we're factoring this side of it. And we would get this, which we can write this way. And I agree, it's weird. But that's one of the things, we hit that one really hard yesterday. So feel free to go back and watch that one. So what could I do here to solve this? I'm going to give myself a little bit more space, and that'll mean I have to change the view.
Square root.
Yeah, we're going to square root both sides. I want to square root both sides to get rid of that square. Because square roots and squares undo each other. So we're going to have our x minus 23 equals what?
Plus or minus.
Plus or minus, because we square root of both sides of an equation. Good. What is the square root of negative 36?
6i.
6i. So we can get imaginary roots this way. Because square root of 36 is 6. Square root of negative 1, that's when it turns imaginary. It's not real anymore. We still need to do our two roots. They're just going to be complex roots. So we're going to have our x minus 23 equals 6i. And our x minus 23 equals negative 6i. And for both of these, what are we going to do? How do I get my x by itself?
Add 23.
Add 23.
It's 1.
It's the square root of negative 1.
Oh, so it's
When it's a negative under a radical. Yes. So what we get is our x equals, can I combine together 23 and 6i?
No.
No. Put them next to each other. We've got 23 plus 6i. On the right-hand side, we've got our x equals 23 minus 6i. And that is as much as we are doing with those imaginary roots. So they're a little extra, a lot extra. But we can do that. That's where these square root properties are going to start coming in. We're going to see those pop up more and more when we have parabolas that have no roots, where they don't cross the x-axis. That's where these come from. If we have roots that are in between values, that's when we're going to start getting decimals or these irrational ones like our last one where we had our 12 minus 8 square root of 3. It's just decimally. So we're going to have a few different ways of solving that, and that's what we're going to work on more next week, on how we can use this on other kinds of equations that are not perfect squares, and on how we can find without having to do perfect square stuff. So I know it's a Friday. I know we're zombies. I know we're tired.
Don't tell me we have homework.
Homework 3.4 is due today. Homework 3.5, at this point you can only do 3 questions on it, so it's going to be your choice if you pick it up or not. We're going to use it Monday and Tuesday, so if you want to wait and get it till then, that's fine. I'm going to put it on my little tray, on my table. Sort it out. Oh, great. 6, because I made all my copies. Right. So if you want to start on homework 5, these are what we did today, these first 3. The rest of what's on here is what we're going to do next week, well, plus the review on the back. But, so if you want to start on homework 5, I'm going to put it up here. However, I know it is a Friday. I know it is a tired. I know we have opening night tonight, and so I get it if we don't want to. So you guys have, but look at that. You have 10 minutes. You can work on things. You can ask questions. All that jazz. Look at that. Look at us with time. I love that.